Hi, welcome to the lesson about the laws of exponents. The laws of exponents will be discussed in series, and this is part 1 of the series. Let us start the lesson with this example. 6 squared times 6 cubed. How will you evaluate or simplify this exponential expression? 6 squared times 6 cubed. From our previous lesson, we know that 6 squared is equal to 6 times 6, and 6 cubed is equal to 6 times 6 times 6. If we get the product of 6 squared and 6 cubed, 6 squared times 6 cubed is therefore 6 times 6 times 6 times 6 times 6. How many 6 are now being multiplied? There are now 5 6s. But 6 times 6 times 6 times 6 times 6 is equal to 6 to the 5th power. Is that right? Yes, that is correct. 6 squared times 6 cubed is therefore equal to 6 to the 5th power. What have you noticed? The new exponent 5 is equal to the sum of the exponents. 6 squared times 6 cubed is actually equal to 6 raised to the power equivalent to the sum of exponents 2 and 3. This is one of the laws of exponents. The product of exponential expressions with the same base is equal to the base raised to the sum of their exponents. Examples: 3 cubed times 3 to the 4th power. 3 cubed times 3 to the 4th power is equal to 3 raised to the power of 3 plus 4. 3 plus 4 equals 7. 3 cubed times 3 to the 4th power is therefore equal to 3 to the 7th power. Next, 2 times 2 cubed times 2 squared. In this example, the exponent of the first number 2 is 1. Remember, if the exponent is not written, it has to be understood that the exponent is 1. 2 times 2 cubed times 2 squared is therefore equal to 2 raised to the power of 1 plus 3 plus 2. 1 plus 3 plus 2 equals 6. 2 times 2 cubed times 2 squared is therefore equal to 2 to the 6th power. Next, 7 to the 5th power times 7 cubed times 8 squared times 8 to the 4th power. Remember, the law of exponents that we are discussing states, the product of exponential expressions with the same base is equal to the base raised to the sum of their exponents. This means the adding of exponents is applicable only for expressions with the same base. In this example, we can simplify the expressions with a base of 7 and the expressions with a base of 8 separately. 7 to the 5th power times 7 cubed times 8 squared times 8 to the 4th power is therefore equal to 7 raised to the power of 5 plus 3 times 8 raised to the power of 2 plus 4. And this is equal to 7 to the 8th power times 8 to the 6th power. Since the bases 7 and 8 are not the same, we can leave the expression as is. The next step actually is to get the actual value of each exponential expression and multiply them. For the purpose of simplicity in this discussion, we will leave it as is. Next example: 1 squared times 1 cubed times 1 to the 4th power. This is equal to 1 to the power of 2 plus 3 plus 4. 2 plus 3 plus 4 equals 9. The expression then becomes 1 to the 9th power. From the previous lesson, we learnt that 1 to any power is equal to 1. 1 squared times 1 cubed times 1 to the 4th power is therefore equal to 1. Welcome to Hippocampus Learning Videos. If you are enjoying the Hippocampus Learning videos, please give us a like, subscribe, and hit that notification bell so you can be notified when new learning videos are added to the channel. Hippocampus ETV is also on Patreon. Please check it out. Happy learning! What about if we have an expression like this one? 2 to the 5th power divided by 2 squared. By the way, this is another way of writing division. The expression on top is the dividend and the one below is the divisor. The division sign is represented by the bar, separating the dividend and the divisor. As you can see, the dividend and the divisor have the same base and the base is 2. How can we perform the operation or simplify the expression? There are several ways to perform this operation. One way is by expanding the dividend. 2 to the 5th power is actually equal to 2 squared times 2 cubed. 2 squared times 2 cubed is then divided by 2 squared. The operation now has 2 squared in the dividend and the divisor. 2 squared divided by 2 squared is equal to 1, or 2 squared in the dividend and the divisor will simply cancel each other out. This leaves 2 cubed in the operation. 2 to the 5th power divided by 2 squared is therefore equal to 2 cubed. What have you noticed? The new exponent, 3, is the difference between the exponents, 5 and 2. Therefore, 2 to the 5th power divided by 2 squared is equal to 2 to the power of 5 minus 2. This is another law of exponents. The quotient of exponential expressions with the same base is equal to the base, raised to the difference of their exponents. Examples: 3 to the 6th power divided by 3 to the 4th power. 3 to the 6th power divided by 3 to the 4th power equals 3 to the power of 6 minus 4. 6 minus 4 equals 2. 3 to the 6th power divided by 3 to the 4th power is therefore equal to 3 squared. Next, 8 to the 9th power divided by 8 cubed. 8 to the 9th power divided by 8 cubed equals 8 to the power of 9 minus 3. 9 minus 3 equals 6. 8 to the 9th power divided by 8 cubed is therefore equal to 8 to the 6th power. Next example: 4 to the 5th power times 4 to the 6th power divided by 4 to the 8th power. In this example, we can perform the operation on top first. 4 to the 5th power times 4 to the 6th power equals 4 to the power of 5 plus 6. We can then just copy the divisor. The expression then becomes 4 to the 11th power divided by 4 to the 8th power. 4 to the 11th power divided by 4 to the 8th power equals 4 to the power of 11 minus 8. 11 minus 8 equals 3. The final and simplified expression therefore is 4 cubed. That ends part 1 of the laws of exponents. In this lesson, we have learnt how to multiply and divide exponential expressions with the same base. More laws of exponents will be covered in the next lessons. Those lessons will give you more examples of manipulating exponential expressions. Please stay tuned. Thank you for joining us in learning this lesson. We hoped you had fun and learned a lot. Please continue studying and continue watching these learning videos. See you in the next lesson. Happy learning!